Space holds an incredible show where entire galaxies dance and merge together. When these cosmic giants meet, they create a spectacular display of light and energy that transforms both galaxies into something completely new. Let's explore this amazing process. Let's zoom in on a remarkable pair of galaxies that are about to perform their cosmic dance, the Andromeda Galaxy and our very own Milky Way. Right now, Andromeda is speeding toward us at 68 miles per second. While that might sound scary, don't worry. This slow-motion collision won't happen for another 4.5 billion years. These two spiral galaxies, each containing hundreds of billions of stars, are being pulled together by gravity. Like two figure skaters approaching each other on cosmic ice, they're gradually picking up speed. Their outer edges are already starting to feel each other's pull, creating long streams of stars and gas that stretch between them. This is just the opening act of a merger that will completely reshape our cosmic neighborhood. When galaxies collide, it's less like a car crash and more like a graceful dance in slow motion. The stars in each galaxy are so far apart that they rarely crash into each other. Instead, the real action happens with gas and dust. These cosmic clouds slam together, creating powerful shock waves that trigger the birth of millions of new stars. The galaxy's gravity pulls and stretches each other, forming beautiful bridges and tails of stars that stretch across space. Think of it like stirring two different colors of paint. They start to mix and swirl together, creating new patterns. During this process, the galaxies might pass through each other several times, like dancers twirling around. Each pass reshapes both galaxies more and more, until they finally merge into one larger galaxy. When galaxies collide, they create perfect conditions for making new stars. The huge clouds of gas and dust in each galaxy crash together like waves on a beach, getting squeezed and compressed. This compression acts like a cosmic pressure cooker, forcing the gas to clump together until it becomes dense enough to spark new stars. Imagine shaking up a snow globe. That's similar to how these collisions stir up the gas clouds. Areas that were once quiet cosmic neighborhoods suddenly light up with thousands of bright young stars. Some of these stellar nurseries can create stars much bigger than our sun, shining hundreds of times brighter. These new stars often form in clusters, creating beautiful bright spots that we can see even from Earth. The Antennae galaxies, for example, are two colliding galaxies where we can watch this stellar baby boom happening right now. While we can see stars and gas colliding in these cosmic mergers, there's another key player that's invisible but incredibly powerful: dark matter. Each galaxy sits in a huge cloud of dark matter that's much bigger than the visible galaxy itself. When galaxies merge, these dark matter clouds are actually the first things to interact. They act like giant invisible hands, pulling the galaxies together and guiding their dance. Dark matter's gravity helps determine how fast the galaxies spin, how they move past each other, and even the final shape they'll take when they merge. Think of dark matter like cosmic puppet strings. We can't see them, but they control much of the show. Scientists can track dark matter's effects by watching how stars and gas move during these collisions. Let's fast forward through time to see how galaxy mergers play out. These cosmic dances happen over millions of years, but we can break it down into key stages. First, the galaxies begin their approach, with their outer edges starting to stretch toward each other. Next comes the first pass, where the galaxies sweep through each other, creating long tails of stars that look like cosmic streamers. Then there's the back and forth phase. The galaxies might separate and come together several times, each pass mixing their stars and gas more thoroughly. Finally, after about 1 billion years of this cosmic tango, the two galaxies settle into their final form. The end result is usually an elliptical galaxy, rounder and larger than either of the original spiral galaxies. When galaxies collide, they create stunning light shows that would put any fireworks display to shame. As the galaxies pull on each other, stars get thrown into long, glowing streams that stretch across space like ribbons of light. Meanwhile, huge clouds of gas crash together at millions of miles per hour, creating massive shockwaves that light up in different colors. These cosmic crashes heat up the gas so much it glows in X-rays, making beautiful purple and blue patterns we can see with special telescopes. Some stars get flung out into space at incredible speeds, creating trails of light behind them. Other stars bunch together in new clusters, glowing like cosmic jewels. While this destruction might sound violent, it creates some of the most beautiful sights in our universe. Galaxies wrapped in glowing arms of gas and stars, shining in colors from deep red to bright blue. You might wonder what happens to planets and solar systems like ours when galaxies crash together. The good news is that stars and their planets are so far apart that direct collisions are super rare. Think about this. If our sun was the size of a grape in New York, the nearest star would be another grape in Las Vegas. But while physical crashes are unlikely, the merger will definitely change how our solar system moves. The growing pull of gravity from both galaxies might push us into a new orbit, giving Earth different views of our newly combined galaxy. Our night sky would slowly transform, filling with bright new stars and colorful gas clouds. Some solar systems might even get tossed into new regions of space like leaves caught in a gentle breeze. After the cosmic dance ends, something amazing happens. A completely new type of galaxy emerges from the merger. The beautiful spiral arms of both galaxies are gone, replaced by a more rounded, football-shaped galaxy called an elliptical. This new galaxy is bigger and brighter than either of the original ones. Most of the gas that once filled both galaxies has either turned into new stars or been blown away by the collision's energy. The stars now move in more random paths, like bees buzzing around a hive instead of following neat circular orbits. Any remaining gas and dust settles into the center, often feeding a supermassive black hole that grows larger from all this cosmic food. Let's peek into our galaxy's future, because the Milky Way is headed for its own cosmic merger. In about 4.5 billion years, we'll combine with our nearest large neighbor, Andromeda, to create what astronomers playfully call Milkdromeda. As these galaxies come together, our night sky will transform dramatically. The Andromeda galaxy will grow bigger and brighter until it fills a large part of our view. Stars from both galaxies will mix together like cosmic confetti, while huge clouds of gas spark the birth of millions of new stars. The final result will be a giant elliptical galaxy, nearly twice the size of either the Milky Way or Andromeda alone. Galaxy mergers haven't just created pretty light shows, they've been key players in shaping our entire universe. Almost every large galaxy we see today, including our Milky Way, is actually a combination of smaller galaxies that merged long ago. These cosmic combinations helped build bigger and more complex galaxies over billions of years. When we look at ancient galaxies from the early universe, we see they were much smaller and simpler than today's giants. It's like watching cities grow. Small settlements joined together to make towns, which merged to create cities, and eventually formed the huge metropolitan areas we have now. Each merger brought new stars, more gas for making stars, and even helped grow the supermassive black holes at galaxy centers. Thanks for joining us on this cosmic journey through colliding galaxies. If you enjoyed learning about these spectacular space events, hit that like button and subscribe for more amazing space content. Share with your fellow astronomy fans. Until next time.